Hello everyone. So in this session of Prelims Probable, I hope that you already have gone through the two sessions of mapping that we have covered, in which we have covered most of the world related mapping as well as India related some important mappings. In this session, we will cover the very important topic from where you will definitely get a question in UPSC Prelims examination. In fact, in some of the year they are having habit of asking 4-5 questions directly like last year 2024. So in today's session we will cover the topics of climate, and we will cover the topics in such a manner that if you will go through the session, this particular session, most of the topics that can be asked as a question in your prelims will definitely get sorted out. So you can rely this lecture for your climate revision for this year's upcoming prelims program. So let's begin. In climate deals with one of the major sphere of the earth. Earth is associated with some of the major sphere. The four major spheres happens to be lithosphere, hydrosphere, atmosphere, which gives the birth to the fourth major sphere, that is the biosphere. Means it is the combination of atmosphere, lithosphere and hydrosphere which makes the life possible on this planet in the form of biosphere. But out of the possibility, the most important sphere for the life happens to be the atmosphere. Atmosphere happens to be the most important, so you need to know that what are the different component that is present in our atmosphere. Simply the atmosphere for any doubt, for any query, if it is not audible, so you all can so I hope that now it is audible now. Okay. All right. So atmosphere is something that is surrounding the earth, and this atmosphere is making the possibility of life on the earth's surface. Now the first thing that you need to remember for your examination, that what is the composition of the atmosphere. Atmosphere is primarily associated with the gases. So atmosphere is a gaseous, that is why it is referred as the gaseous atmosphere. Now in this atmosphere we have a large number of gases, and these gases are primarily being grouped in two categories: permanent gases and variable gases. So permanent component of the atmosphere and the variable component of the atmosphere. Permanent component of the atmosphere is primarily nitrogen, oxygen and some of the inert gases. Inert gases like argon, neon, xenon, krypton, so all these. In fact, nitrogen comprised of around 78%, oxygen comprised of around 21%, argon's proportion is around 0.9%. So, in permanent we have nitrogen 78%, oxygen 21%, argon around 0.9%, whereas in temporary this is also known as variable component, not temporary, variable component. In variable component, some of the gases that are very important is the carbon dioxide, then we have a presence of water vapor, then we have a presence of aerosol, and these aerosols are also known as particulate matters. Within the particulate matters, we have the salt particles, we have the ice crystals, we have the dust particulate matters. So, in our atmosphere, these are the major gases and materials that are present. It is not a big deal. I am sure that all of you will have some idea. जिन्होंने भी preparation किया है, revision किया होगा, तो आपको ये idea होगा that these are the major gases, these are the major materials that are present in atmosphere. Now, what are the things that you need to know around these fact, around these information? So, the very first thing that you need to know, this is the composition of atmosphere, but how these composition, how these materials have been added. So, the very first thing that you need to know is from where these materials have been added, and the second thing, what is the role that these materials are playing. Now, the first we will cover is the role played by these materials. Nitrogen is very important, and in fact is very important in the living beings. So, it helps in the growth of living beings. Soil में भी आपको nitrogen की जरूरत होती है. In fact, to improve the fertility of the soil, we utilize the urea, that is nothing but the major proportion of the nitrogen. So, nitrogen is very important, and oxygen is a life-giving gas. We can survive without the food and water for few minutes, for few hours, but it is not possible for us to survive without the breathing oxygen. So, both of these gases are very important from the living perspective. But when we talk about the climate, when we look out the climatic phenomena, atmospheric phenomena, climatic phenomena is not driven by these proportions of the atmosphere. Means this part of the atmosphere is not important from the atmospheric perspective. From the atmospheric perspective, this part of the atmosphere is important because these are variable and they are known to show the greenhouse effect. So, the very first thing that you need to have clarity, and you need to know that in our atmosphere there are different gases and materials that are present, but out of all the gases, materials are not directly associated with the climatic phenomena, atmospheric phenomena. Atmospheric phenomena are primarily being driven by the greenhouse gases, the material, the component of atmosphere which is known for the showing characteristic of greenhouse gases. And here the two important component that you need to know, one is carbon dioxide and another one is the water vapor. Carbon dioxide and water vapor happens to be very important role. Other than this particulate matters also plays important role, but particulate matter has one more another role. In our atmosphere, one very important phenomena is rainfall, and rainfall happens through the clouds. So, जो clouds आपके बनते हैं, cloud formation process will be very much associated with the particulate matters. In absence of particulate matter, the possibility of cloud formation will not happen. So, cloud formation is almost going to be absent in those areas where there is no presence of the particulate matter, and these are also known as hygroscopic nuclei. So, for this characteristic, because from around this ice crystal, around this dust particles, there is a process of condensation. So condensation takes place around the particulate matters, and these particulate matters are simply known as the hygroscopic nuclei in terminology of that particular condensation process. So from the condensation process, from the rainfall process perspective also, it is going to be very crucial. So the utility of the atmosphere for our atmospheric phenomena is limited to the greenhouse gases, not the permanent gases. So the first thing that you need to remember, the role of different components of our atmosphere. Now the second point that you need to know, how these gases have been added. How these gases have been added. So let's have some understanding, quick understanding related to the arrival of gases. We believe that the earth came into existence around 4.6 billion years ago. So the evolution of earth is around 4600 million years. And there has been a different phenomena processes that has taken place. We are not going in that detail. There are different phenomena and processes that taken place which ultimately resulted into the evolution oncoming of oxygen. So oxygen has been added around 2500 million years ago. In a way you can say roughly it took 2100 million years for the oncoming of oxygen. So oxygen has not been added immediately. In fact, all the atmospheric components, gases, materials have not been added at the time of formation of the earth, at the time of evolution of the earth. So if the question will be asked, पहले भी पूछा गया है, so the very first thing that you need to know, if the question will be asked that atmospheric components, atmospheric elements have been modified later on, so the very first thing that you need to remember is answer will be yes. So atmospheric components आपके evolve हुए हैं over the period of time. It has not been added in one go. There has been a different phenomena processes which ultimately resulted into the evolution of the different component of atmosphere. Now here what you just need to understand, when the earth came into existence, it was not in the present form. The first change that earth has witnessed is the formation of the crust. So two crusts came into existence in the form of oceanic crust and continental crust. Oceanic crust and continental crust formed means solidification was taking place, and when the solidification was taking place, there was still some of the gaps that were present over the earth's surface, and from that gaps materials, gases have been coming out from the earth interior. Means when the earth was getting solidified, so earth was getting solidified, there was some gap, and through that gap, because of density differentiation, some materials, some gases came out, and this process is known as degassing. So in the process of solidification of the earth, degassing takes place, and degassing happens to be responsible for the addition of most of the gases, most of the materials in our atmosphere. So through the process of degassing, which of the materials, which of the gases have been added? The very important gas that have been added is nitrogen. So nitrogen have been added from the earth interior. Earth interior. Along with the nitrogen, carbon dioxide has also been added from the earth interior. Inert gases, so most of the inert gases have been added from the earth interior. So inert gases like the gases of argon, krypton, neon, xenon, all these gases have been added from the earth interior. Then Also you will have a water vapor. Water vapor has also been added from the earth interior. In fact, different particulate matters have also been added. So here you can see nitrogen, carbon dioxide, inert gases, water vapor, everything has been added from the earth interior, but not the oxygen. So one very important fact, one very important point that you need to remember, that out of all the atmospheric components that are present in our present day atmosphere, most of the component has been added from the earth interior, but not the oxygen. So oxygen not been added from the earth interior, oxygen has been added later on. So here comes, there are two things that you need to know, और question भी पूछा जा चुका है. So already the question has been asked on this. How the oxygen has been added and what was the ramification of not having the oxygen but other gases were present. So these two things you should have clarity. The very first thing is, oxygen has not been added through this carbon dioxide or inert or water vapor, because when the water vapor will be taken upside, there is a possibility of breaking of water vapor in the form of hydrogen and oxygen. Similarly, the CO2 is there, so CO2 can also be broken in the form of carbon and oxygen. The very first thing that you should have clarity, if question will be asked, you should not have any kind of doubt. तो यहाँ पे कोई डाउट, कोई कंफ्यूजन किसी भी सोर्स के थ्रू आपको ये नहीं होना चाहिए. ऑक्सीजन हैज नॉट बीन एडेड फ्रॉम द एबव. सो इन आवर एटमॉस्फेयर ऑक्सीजन हैज नॉट बीन एडेड फ्रॉम द एबव, क्योंकि एबव एटमॉस्फेयर ऐड होने के लिए क्या होना पड़ेगा, दैट दिस इज दिस सरफेस and from the surface water vapor is being released. So here water vapor is being taken and then there is a breaking of water vapor in the form of hydrogen and oxygen. Similarly, the carbon dioxide is taken and there is a breaking. So once the carbon dioxide is broken, once the water vapor is broken, then oxygen will be released and that oxygen is coming downward. That is not the case. So oxygen has not been added from the above. Oxygen in our atmosphere has been added from the below, but not from the earth interior. This is the important fact that you need to know. So oxygen has been added from the below, but not from the earth interior. And the one important information you already have, that oxygen has been added later on. So initial form of the atmosphere came into existence because carbon dioxide is there, inert gas is there, water vapor is there, nitrogen is there. So the more or less major components of the atmospheres are present. The only thing missing in our atmosphere at that time was the oxygen. And in fact, if oxygen is not there, so there is no possibility of life. So life's possibility will not be there. Now there are few additional things that you can learn from here. Initially, when the earth came into existence, there was two missing component. Earth gravitational pull was not that much strong. So earth gravitational pull was not that much strong, and also earth was not magnetized. In the absence of magnetism, the magnetosphere was not there. So in the absence of magnetism, solar flares, solar winds were capable of taking away all the gases that were present in the at the time of evolution of the earth, that is 4600 million years ago. So initial atmosphere has been completely taken away, जिसको हम लोग कहते हैं primordial atmosphere. Later on, when the earth started developing the different layers, we have oncoming of crust, mantle and core. Within the core we have the outer core and inner core, and in outer core material was in molten form and the inner core material happens to be in a solid form, and both the materials are primarily dominated by the iron. Because of that, circulation of the materials in the outer core, Earth got magnetized. The moment Earth got magnetized, magnetosphere became very strong, and when the magnetosphere became very strong, now the solar flares are not capable of, solar winds are not capable of taking away all the gases, materials. So now whatever the gases will come into existence, it will not be directly impacted by the solar flare. तो ये जो आपका नाइट्रोजन है, आपकी जितनी भी गैसेज आई हैं, now all these gases will remain within the earth atmosphere, within the earth gravity. The second thing, initially the earth gravitational pull was not strong, now the earth gravitational pull is also very strong. So when the gravitational pull became strong, as well as earth got magnetized, so all the materials, gases that are now being added in atmosphere will remain within the atmosphere. So that is why initial atmosphere has been taken away, but later on atmosphere has started settling. So atmosphere has started settling around the earth in the form of blanket. That is why we call it as atmosphere is nothing but it is the blanket of gases that surrounds the earth, mixture of gases that surround the earth. So this is also one of the very important fact that you should know. Now coming to this oxygen, that how the oxygen has been added, किस तरीके से oxygen आपके atmosphere में add की गई. When the water vapor released, because earth initially was very hot, so when the earth came into existence it was very hot, water vapor got released from the earth interior through the degassing. Now this water vapor has been taken above, and through the rising of this water vapor, the primitive form, the first form of the condensation has taken place, and this condensation has resulted into the development of the cloud. So the first form of cloud developed through this water vapor that was released from the earth interior, and this cloud resulted into the rainfall. But this rainfall was not a rainfall like how we witness the rainfall in the present time period. It was more or less like a rainfall that was continuously happening for almost lakhs of years. So earth has witnessed a continuous rainfall for the lakhs of years, and this continuous rainfall has ultimately resulted into the outpouring, downpouring of huge amount of water on the earth's surface. Now by that time period already the depression has been created, crust has been formed. So whatever the rainfall is happening, whatever the water is coming, all these water will start accumulating in a depression, and this accumulation of the water in the depression has resulted into the formation of the ocean. So the primitive water vapor, initial water vapor that has been released from the earth interior through the degassing, so जो आपका water degassing से through release हुआ, degassing के through water release हुआ water vapor, और ये water vapor आपका because of the heating has taken above, ultimately condensation has taken place, resulted into the development of cloud. Now this cloud has started raining, and through this rainfall what has happened, the formation of the oceans. So oceans formed on the earth's surface. Now in this ocean, and all these process was taking place not randomly, it is in the geological time period. When the ocean came into existence, over the period of time, the temperature of the earth lowers, it gone down, and because of the lowering of the temperature on the earth's surface over the period of time, ocean became very much suitable for the oncoming arrival of the living. And in the ocean, very first organism evolved, that is cyanobacteria or blue-green algae. So blue-green algae came into existence, and this blue-green algae, when it came into existence within the ocean, this blue-green algae has done the first anaerobic photosynthesis. Now this anaerobic photosynthesis that the cyanobacteria has done, through this anaerobic photosynthesis, ultimately oxygen has been added. So this is very interesting that how the oxygen has been added. Oxygen has been added by the livings. Sometimes in this evolution, that how the livings came into existence, whether it was the earlier oxygen was present and then the living arrived, or the living arrived without the oxygen. So you should have clarity, you should not have any kind of doubt that oxygen has been added later on. First you will have a single cell animal, you will have a cyanobacteria that came into existence in the ocean, and they have done the process of photosynthesis, through that oxygen has been added. In fact, this has also been asked as a question. तो ये भी question पूछा जा चुका है, where they have asked the question like living have modified the atmosphere, because living, it is the living organism which has brought the oxygen, and oxygen happens to be the major component of atmosphere. So we can say that yes, our atmosphere is being directly modified by the living organism. There is no doubt about it. There is no doubt about it that our atmosphere is being added. So this is the process how the some of the component of the atmosphere has been added. So degassing, through the degassing, most of the gases have been added, most of the materials have been added, but not the oxygen. Oxygen has been added in our atmosphere in later on and through this process. तो ये process आप याद रखिएगा कि किस तरीके से ऑक्सीजन हमारा ऐड हुआ है. So in our atmosphere we have a nitrogen, oxygen, argon, xenon, neon, hydrogen, helium, krypton, carbon dioxide, all these gases are present. Now quickly look out one more component of our atmosphere, that is water vapor. So water vapor के बारे में कुछ we will learn few important things, and as I said that atmosphere is primarily, that the component of atmosphere is primarily grouped in two categories, permanent component and the variable component. And in the starting itself I made it very clear that for the atmosphere, for the climatology, climatic phenomena, it is the variable component of the atmosphere that is responsible, not the permanent component. So variable component, why it is important? Because variable component is known to exhibit the greenhouse effect. So what is this greenhouse effect? What is the role of this greenhouse effect, and also about the water. Water vapor happens to be one of the component of the variable gases. Now water vapor is nothing but the gaseous form of water. So gaseous form of water. Now one thing that you need to remember, this water vapor will turn from the water through the process of vaporization. You should not have any doubt in this. See, in climatology, the questions are being asked in such a manner that if your concept will not be cleared, if you will try to think too much if you are not having the clarity of one concept and you will try to think, if you will try to apply the another concept, and through the another concept you will try to solve one concept on which the question is being asked, there will be chances that you will commit the mistake. In fact, last year from the climatology they have asked 4 questions and all the questions were associated with the atmosphere. So atmosphere से बहुत easy question पूछे गए थे, but you should have clarity. And lot of time you will find the students are very much concerned about the polar vortex. Student is very much concerned about the some of the higher concept of atmosphere, but they are asking the question. They are asking the question that is very simple, but requires high conceptual clarity. And those conceptual clarity even you will not find in most of the conventional book. That is why they are asking this type of very which appears to be very easy. Temperature पे सवाल पूछ रहे हैं. So temperature पे question पूछा जा रहा, so it appears कि temperature में क्या बड़ी बात है. But majority of the question, when you will sit in the examination, those who have given the last year's the prelim, they must be knowing that how hard it is to solve those questions if you are not having the clarity of the temperature variation, how the temperature varies. So, water will transform into the water vapor through the process of vaporization. Now, the only thing that you need to remember for this water vapor, that in our atmosphere we have a water vapor, but the source of that water vapor is a water, and that water is at the surface. It's as simple as that. No need to bring any kind of complexity. So, the source of water lies on the surface. Surface पे variation होगा. Lower latitude more water, higher latitude lesser amount of water. But the very first thing that you need to have clarity, that source of water vapor is on the surface. And if the source of water is on the surface, so obviously the higher amount of water vapor will be present on the surface. As you will move away from the surface, so let's say the question is being asked that where the proportion of water vapor will be higher, on the ground or above atmosphere. So you need not to think of anything. Don't bring complexity that they are matching the low latitude surface and the higher latitude atmosphere, nothing like that. Keep it very simple that whenever there is an increase in altitude, increase in height, source of water is on the surface. So as you will go upside, definitely the amount of water vapor decreases. So higher amount of water vapor you will find on the surface, lesser amount of water vapor you will find in above atmosphere, means with the increasing height, amount of water vapor will decreases. With the increasing height, amount of water vapor will go down. The second, as higher temperature prevails over the lower latitude, so it's obvious that in low latitude the amount of water vapor will be more as compared to higher latitude. So water vapor proportion is higher in lower latitudes compared to higher latitudes. In fact, in lower latitude, the proportion of in lower latitude, the proportion of water vapor is sometimes around up to 4% of the volume of the atmosphere. So we have a huge amount of atmosphere, and this is all, these are very much linked. Wherever you will have a higher amount of water vapor, there you will have a chances of more rainfall. That is why the majority of the rainfall on the earth's surface is being witnessed on the low latitude in comparison to the higher latitude. Because in higher latitude, the source of water is lesser, water vapor is lesser. That is also one of the reasons that why rainfall will be lesser. Both of these concepts are very important, and there has been question that has been asked, and definitely in future also they will ask this question, they will ask the question on this. You should not have any clarity, you should try to learn it very simply that the source of water vapor is on the surface. सरफेस से ही आपका वाटर वेपर वेपराइज होगा. जब भी वेपराइजेशन होता है, स्टेट चेंज होती है, तो देयर विल बी सम ऑफ द लेटेंट हीट दैट विल गेट स्टोर्ड. सो वेपराइजेशन है, वेपराइजेशन से ही आपका वाटर वेपर बन रहा है और सोर्स आपका सरफेस पे है, तो इट्स अ वेरी ऑब्वियस दैट एज यू विल गो अप साइड, सो द अमाउंट ऑफ वाटर वेपर विल डिक्रीजेस. Also the lower latitude have higher amount of water vapor as compared to the higher latitude. So these are the two important concept that you should not miss related to the water vapor. Now, one more interesting information about the variable component of atmosphere. So, variable component of atmosphere. Variable component of atmosphere is nothing but it is the carbon dioxide, your water vapor, dust particulate. But what you just need to know, these are known to have greenhouse effect. So इसी वजह से इनको greenhouse gases भी कहते, sometimes they are referred as the greenhouse gases. The very first thing is that what is the greenhouse effect, and does the gases present in our atmosphere, they are known to exhibit exactly the same characteristic that is being shown by the perfect greenhouse. So these are the two things that you should be knowing. So you should be knowing these two things. Very first thing that you need to know, generally in our Earth surface, the source of energy is the sunlight, and sunlight we receive in the form of insolation, that is incoming short wave radiation. So on the Earth's surface, sunlight comes in the form of incoming short wave solar radiation. Now, out of this incoming short wave solar radiation, the infrared radiation that is coming, it is not the only this insolation is not only having one band, there are different bands. There will be visible light, there will be UV rays. तो जैसे UV rays होती है हमारे एटमॉस्फेयर में, हमारा एक लेयर है, that is stratosphere. So stratosphere is having a presence of ozone, and those UV rays are being obstructed by that band of ozone. So visible light है, infrared है, आपका UV band है. So this short wave radiation will come, and there will be a different component of atmosphere that will try to utilize this short wave, but there will be a major proportion of this short wave that will be received on the earth. So on the earth surface, short wave will be received. Over the period of time, the short wave insolation will be utilized, and ultimately the earth will also radiate. So when the earth radiates in the form of long wave. Outgoing long wave terrestrial radiation. So in case of radiation, there are radiation happens to be in the wave form, and there will be two wavelength, that is the short wavelength and the long wavelength. So short wavelength and long wavelength. Now coming to our discussion of greenhouse, what you need to remember, in a perfect greenhouse will be very much allowing so any perfect greenhouse, what it will do, it will allow the incoming. So incoming rays will be allowed, but outgoing rays will not be allowed. For the outgoing, it will be behave like a opaque. So incoming will be allowed, but outgoing will not be allowed. A glimpse of this greenhouse you can see during the summer season. If your vehicle, if your car is parked in the open area where there is a direct sunlight, if you will almost switch off the car, and your car is parked for few minutes. Within a few minutes you will find inside the car there will be very high temperature. Why there is a very high temperature? And in fact temperature can be 10 to 15 degrees Celsius higher than the outside temperature. So why come you will have such a high temperature? It is simply because of the greenhouse effect. So this is the true greenhouse effect, in which the incoming radiation will be allowed but outgoing radiation will not be allowed. So when the incoming radiation is being allowed but outgoing is not being allowed, that is referred as the true greenhouse. But in our atmosphere we are not having the true greenhouse. This is one of the misconception some of the students develop over the period of time, but you need to have clarity on this. In our atmosphere we are not having the true greenhouse effect, because if you will have the true greenhouse effect, over the period of time Earth's temperature will keep on changing. Our temperature is not continuously rising, our temperature on the earth surface is being maintained. तो टेम्परेचर हमारा मेंटेन होता है सरफेस पे, ऐसा नहीं कि टेम्परेचर हमारा केवल बढ़ रहा है, राइजिंग, बिकॉज इफ द टेम्परेचर विल कंटिन्यू टू राइज, in this case you will have a possibility of continuously rising the temperature, because the only incoming is being allowed and outgoing is not being allowed. Outgoing के लिए ओपेक की तरह काम कर रहा है. So in this case temperature will continue to rise, but in our atmosphere on the earth surface temperature is not continuously rising. So the gases are exhibiting some greenhouse effect, but they are not exactly exhibiting this kind of behavior. More or less the greenhouse effect that the gases are showing in our atmosphere like blanket. So they are regulating, like how you will have a regulator in your houses. Whenever there is a summer, so you will have tendency, whenever there is a high temperature you will have tendency to just increase the speed of the fan. But if the temperature is little bit lesser, let's say it's a rainy day, so what you will do, you will just decrease the speed of the fan. Very similarly our atmospheric gases are also controlling the temperature, and any change in that greenhouse gas proportion obviously is capable of changing that regulation. तो वो regulation आपका जो है वो obstruct होगा, और वही regulation obstruct होगा तो there can be rising high increasing temperature, then can be decreasing temperature, और उसी को आप पढ़ते हैं, उसी को आप जानते हैं in the form of climate change. So climate change is not something that there is a only increase, there can be increase, there can be decrease, and this is very much associated with this variable component of the atmosphere. So variable components of the atmosphere primarily plays in our atmosphere, because the gases present in the variable component of atmosphere or in atmosphere, these are known to exhibit the greenhouse effect. This is the very important component, this is the very important point that you need to know. Now moving to the next discussion. Next discussion is also very important, regularly questions will be asked. Next discussion is associated with the structure of atmosphere. So our atmosphere will have a different layers. तो हमारी atmosphere में different layers हैं. अब कौन कौन सी layers हैं हमारी atmosphere में? In our atmosphere we have the different layer, and these layers are known as troposphere, stratosphere, mesosphere, exosphere or thermosphere. Within the thermosphere we have an exosphere, we have an ionosphere. So we have a troposphere, stratosphere, mesosphere and the thermosphere. Troposphere extent is more over the equator in comparison to the pole. So equator पे height troposphere की थोड़ी ज़्यादा है. and almost it is 16 kilometer. Here we have around 6 kilometer. Now, some quick point, troposphere is known for most of the atmospheric phenomena. So, majority of the atmospheric phenomena is very much limited to the troposphere. So, most of the atmospheric phenomena is very much limited to the troposphere, be it your cloud formation, be it your rainfall. So, all those things will be associated with the troposphere only. In troposphere, temperature decreases with increasing height. So, in troposphere, temperature decreases with increasing height, and this rate of decrease of temperature is around 6.5 degrees Celsius, and it is simply referred as the normal lapse rate, environmental lapse rate. तो जो हमारा normal lapse rate है, जो हमारा environmental lapse rate है, that is associated with the lower part of the atmosphere. In fact, this is also the general vertical distribution of temperature. तो वर्टिकल डिस्ट्रीब्यूशन ऑफ टेम्परेचर में आपको क्या याद रखना है कि जब भी आप टेम्परेचर, जब भी आप सरफेस से ऊपर जाएंगे, whenever there is a increase in height, there will be decrease in temperature. Now the question arises, यहीं पे, here itself you can have the clarity of this point. Why the temperature is decreasing as we are moving upside? Because in on the Earth's surface, most of the heating and cooling is being associated, is being regulated by the atmosphere. The source of heat is the insolation, but the heating and cooling phenomena is being primarily managed by the atmosphere. So, because it is being managed by the atmosphere, atmosphere is not directly acting on the insolation that is coming from the above. Major portions of the heat which atmosphere will utilize for the maintaining the temperature, maintaining the atmospheric phenomena, comes from the below. That is why we generally call that our earth gets heated from the below. It is not that the entire source of heat is coming from the below, but most of the heat that is being utilized by the atmosphere for the regulation of the temperature on the earth surface comes from the below. Because the heat is coming from the below, so it's a very common, it's a very obvious that as you are going away from the source, because the source is surface, so heat source आपका surface से है. So as you will go away from the heat source, temperature will decrease. In fact, this is the simple reason why in the mountainous area, if you will go to mountains, you will always find that the mountainous area's temperature is lesser than the temperature of the plain area, because you are traveling, you are going to some certain height, altitude. तो जैसे ही आपका altitude बढ़ेगा, there will be decrease in temperature. Now coming to the stratosphere. No, one more thing. There is one more information जहाँ से question पूछा जाता है. In troposphere, that is the lower part of the atmosphere, we have the two different areas. One is the higher latitude, one is the lower latitude. Higher latitude poles, lower latitude equator. So at the upper boundary of the troposphere, the temperature will always be lesser over the equator in comparison to the pole. Why over the equator temperature will be lesser? Because the equator we have the higher height. So above the equator, above the troposphere, that is the boundary zone of troposphere, this boundary zone of troposphere is being represented by a thin layer, and this thin layer is simply known as tropopause. So it is around 1.5 kilometer thick layer where everything will stop. So at this nearby the tropopause, you will find temperature of above equator will be lesser than the temperature of above poles. Generally here the temperature can reach up to minus 40 degrees Celsius. So temperature can reach up to minus 40 degrees Celsius above this tropopause. As you will go to the stratosphere is known for the presence of ozone. तो यहाँ पे आपको ओजोन मिलेगी, but temperature के हिसाब से here temperature again will increases. So in troposphere temperature is decreasing as you are going up. here temperature will increases, and in fact upper boundary of stratosphere temperature will reaches up to the 0 degree Celsius. In mesosphere again the temperature will decreases, तो temperature फिर से decrease करेगा, and in fact upper boundary of mesosphere we will witness the lowest temperature of our atmosphere. So lowest temperature of our atmosphere is being witnessed by the lowest temperature of atmosphere. It can range anything between minus 80 degree to minus 130 degree Celsius. Here in thermosphere again we have a presence of ions, because of that it is also known as ionosphere, well suited for the transmission, radio transmission. Also this zone is known for the phenomena of lightning. So lightning phenomena जिसको आप कहते हैं aurora. So auroras are being witnessed in the thermosphere. So phenomena of lightning, auroras are associated with the thermosphere, and these auroras, lightning are nothing but these are the mostly associated with the solar flare. So when the solar flare is coming, it is almost most part of the outer side of the earth, magnetosphere will obstruct it, but nearby the higher latitude it will have capability to enter to certain extent of the atmosphere, and it can reach up to the thermosphere where it will produce the lightning phenomena. These lightning phenomena are referred as auroras. That is northern area it is known as northern light, southern area it is known as the southern light. तो northern में आप इसे कहेंगे aurora borealis, and in southern side it is known as aurora australis. So aurora borealis, aurora australis, it is simply known. So these are the some of the information associated with the atmosphere. Now moving to the next discussion, and next discussion is again very simple topic from where the questions regularly being asked, and there are lots of confusion among the student. So that is the temperature. So on the earth surface the main source of temperature is the insolation, but the insolation varies from place to place. There are different amount of insolation is being received, that is why there will be variation of the temperature. So on the earth surface temperature is not uniform, so there will be variation of the temperature. So what are the some of the factors, causes of the variation of temperature? So one is latitude. So latitude is the one very important factor for the variation of the temperature. In lower latitude you will find temperature is generally higher in comparison to the higher latitude. So when you will look out latitudinal distribution, you will find temperature will keep on decreasing from low latitude to the higher latitude. Temperature will keep on decreasing from low latitude to the higher latitude. Other than the latitude, we also have altitude. Altitude is simply with the rising height, increasing height, temperature will decrease, and the rate of decrease of temperature is simply known as the normal lapse rate. तो जो हमारा normal lapse rate है, normal lapse rate, that is associated with the altitude, that is height. Then we have a distance from the sea. Distance from the sea very important. You will find that the places that are nearby the ocean, they will have oceanic effect. During the daytime it will be affected by the sea breeze, during the night time it will be affected by the land breeze. So land breeze and sea breeze will affect the temperature, and in simple word what you just need to remember is that the coastal area temperature will always be moderate, whereas the interior part will always be having the extreme temperature, and higher temperature, that is highest and lowest temperature is known as range. Now let's say we have a Delhi. So in Delhi summer season we have a temperature that is 50 degree, and in winter season temperature is 0 degree. So that is the range of temperature, that is roughly 50 degrees Celsius. But in Chennai, if you look out, in Chennai summer temperature is 40 degree and winter temperature is 20 degree. So range is 20 degree. So what you just need to remember, the effect of this distance from the sea. तो ये डिस्टेंस फ्रॉम द सी का जो इफेक्ट आपको याद रखना है, बिकॉज ऑफ दिस डिस्टेंस कोस्टल एरियाज विल हैव लो रेंज ऑफ टेम्परेचर, और इंटीरियर में इसका अपोजिट होगा. सो कोस्टल एरिया वी हैव अ लो रेंज ऑफ टेम्परेचर, वेयर एज इंटीरियर. So in simple, if you have been asked where there will be highest temperature within India, so highest temperature within India will not be recorded in the coastal area. Highest temperature within India can only be recorded in the interior part, not the coastal area. Very similarly, the lowest temperature will also not be recorded in the coastal area. Lowest temperature should also be in the interior part. So distance from the sea will always bring the moderating effect, and this moderating effect is associated with the range of temperature. Then other than the distance of sea, other factors that play in the controlling of temperature, one is the role of ocean current. So role of ocean current, we have a cold ocean current, we have a warm ocean current. So in the area where we have a cold ocean current, definitely temperature will go down. In the areas where we have the warm ocean current, temperature will rise. So higher temperature will be witnessed in the warm ocean current. In fact, this role of ocean current becomes more interesting in the higher latitude. So in higher latitude, whenever the area, last year there was a question, so you need to take care. So whenever you are solving the questions of ocean, don't rely on the only factors. Just try to look out that do we have any ocean current, like in case of northern Europe. So when you will look out northern Europe, Scandinavian area, in Scandinavian area nearby this Scandinavian Ocean, you will find we have a presence of North Atlantic drift. North Atlantic drift is a warm ocean current, and due to presence of North Atlantic drift, Northern Atlantic will be bit warmer. So land से आपकी जो temperature होगी ocean में वो ज़्यादा होगी. So ocean current plays very important role, specifically in the higher latitude. Similar to this ocean current, we also have the role of local winds. Local winds, how it plays the role, we have the best example of local wind is in the form of Chinook. So you will not find any other wind as important effect as the Chinook, Fawn, Zonda, Sant Ana. So these are the winds that are primarily blowing in the winter season, cold condition. During the cold condition, Chinook is blowing, Fawn is blowing, Zonda is blowing, Sant Ana is blowing, and because of this blowing of these local winds, temperature will increases. In fact, you can visualize these winds like, imagine a situation. I am sure that most of the people living in India, specifically in the northern India, they must be aware of the loo. So during the summer season, we have a condition of the loo. Now imagine, just try to think that is hypothetical for India, but you can think of it कि आप विंटर सीजन में हैं, नवंबर दिसंबर का महीना है, और नवंबर दिसंबर के महीने में अगर आपकी लू चलने लगे, सो लू चलने से क्या इफेक्ट होगा. सो नवंबर दिसंबर के महीने में जैसे इंडिया में खास करके आपका यूपी, बिहार, राजस्थान, हरियाणा, इस एरिया में अगर आपकी लू चलने लगे तो क्या इफेक्ट होगा. द वेरी सिमिलर इफेक्ट यू कैन सी in case of eastern part of Rocky Mountain, where the Chinook is blowing during the winter season, and because of the blowing of the Chinook, most of the area is suitable for the agriculture, and that is why this Chinook is got this terminology, that is the snow eater. So, the local winds also plays very important role in controlling the temperature. Other than these, one more factor that you should consider and you should be knowing, that is the surface. There are primarily two surfaces. If you look out from the small scale, within the India, you will have a rural and urban area. But we are looking out at the macro scale, at the large scale. So, we have a two surface, that is ocean and land. So, on the earth surface, we have a two surface, that is ocean and land, and both the surface heating pattern, cooling pattern is different. Oceans gets heated slowly and it gets cooled slowly, whereas the land gets heated rapidly and gets cooled rapidly. So, both it gets heated as well as cooled rapidly, means land का जो temperature होगा, over the land temperature will rise suddenly, temperature will go down suddenly. In comparison, the ocean's temperature will not go up suddenly, also it will not go down suddenly. And why it happens? It mainly happens because the oceans will have higher specific heat. So, the ocean's specific heat is higher in comparison to the land. Oceans has higher specific heat. So, why the oceans gets heated slowly and gets cooled slowly? Because of high specific heat of the water, high specific heat of the water. So, these are the factors that plays very important role in the temperature variation. Now, when you will look out the horizontal temperature distribution on the earth surface, in simple, latitude plays very important role, and in latitude generally temperature decreases from the equator towards pole. But one thing that you always need to remember, temperature will not be highest at the equator. That is valid for the ocean as well. So, in case of ocean also it follows. So, temperature will not be highest at the equator, temperature will always be higher little bit away from the equator, that is subtropics. So, this thing that you need to know, temperature will not be highest at equator, rather at tropics. So, important fact. So, temperature will not be highest at the equator, it will be tropics. The second fact that you should be knowing, highest temperature and lowest temperature will always be recorded over land. So, highest temperature will be recorded over the land, lowest temperature will be recorded over the land. So, highest as well as lowest temperature will always be recorded over the land, not the ocean. You should not have an iota of doubt. Never ever have any kind of doubt in this. So, always remember, जब भी temperature की बात होगी, whenever you are supposed to look out the highest temperature, whenever you are supposed to look out the lowest temperature, highest temperature will be recorded over the land and the lowest temperature will also be recorded over the land. Of course, at the same time, highest and lowest will not be recorded. So, highest temperature will be recorded in summer and lowest will be recorded in the winter. And in fact, summer and winter will be different in case of northern hemisphere and in the southern hemisphere. तो नॉर्दर्न में समर अलग होगी, सदर्न में समर अलग होगी, नॉर्दर्न में विंटर अलग होगा, सदर्न में विंटर अलग होगा. सो यू शुड नॉट हैव दैट कंफ्यूजन बिकॉज एग्जामिनर विल डेफिनेटली ट्राई टू कंफ्यूज यू. Even if you are clear about this, that the highest temperature will be recorded over the land, lowest temperature will be recorded over the land, still the examiner will try to confuse you. So quickly let's have a look of the highest and lowest temperature. तो जो आपका northern summer है, northern summer will be in the month of July, June July. तो जो जुलाई में आपका टेम्परेचर होगा वो ट्रॉपिक्स में हाईएस्ट होगा. सो हाईएस्ट टेम्परेचर विल बी जुलाई, बट जुलाई विल बी विंटर सीजन ड्यूरिंग द इन सदर्न हेमिस्फीयर. सो सदर्न में लोएस्ट टेम्परेचर होगा. सो हाईएस्ट टेम्परेचर ऑन अर्थ सरफेस, highest temperature on Earth's surface will be recorded during the July month over the northern tropics. Lowest temperature on the Earth, lowest temperature on the Earth will be recorded over Antarctica in the same month, that is July. Now comes another interesting point. When it is the winter season, क्योंकि लोएस्ट टेम्परेचर ऑन द अर्थ सरफेस तो हो गया आपका, बट नाउ द लोएस्ट टेम्परेचर विद इन द नॉर्थ, दैट माइट नॉट बी द लोएस्ट टेम्परेचर, बट स्टिल इट इज द लोएस्ट टेम्परेचर विद इन द नॉर्दर्न हेमिस्फीयर. सो इन नॉर्दर्न हेमिस्फीयर लोएस्ट टेम्परेचर विल बी रिकॉर्डेड इन नॉर्दर्न हेमिस्फीयर. लोएस्ट टेम्परेचर will be recorded in January month. So it will be recorded in January month, hundreds of kilometer south of Arctic Ocean or poles, better to write as a south of poles in रशियन साइबेरिया. तो ऐसा क्यों? बिकॉज जो हमारा नॉर्दर्न साइड है, जो नॉर्दर्न पोलर एरिया है, दैट नॉर्दर्न पोलर एरिया इज रिप्रेजेंटेड बाय प्राइमरली द आर्कटिक. आर्कटिक मीन्स वाटर. सो हियर कम्स द रोल ऑफ सरफेस. सो लोएस्ट टेम्परेचर विल ऑल्सो नॉट बी रिकॉर्डेड ओवर द वाटर. लोएस्ट टेम्परेचर विल ऑल्सो बी रिकॉर्डेड ओवर द लैंड. सो इट इज द रीजन of this that the lowest temperature will be recorded little bit south of the poles area, not exactly over the polar area. So this is the temperature distribution on the earth surface, that is the horizontal temperature distribution. So ये आपका horizontal temperature distribution है. Now moving to the next part of our discussion, and let's have a look of another component of the climate, and this is the atmospheric pressure. Atmospheric pressure. On the Earth's surface, atmospheric pressure is being distributed in such a manner that it covers a particular area, and that zone is referred as the belt. So we have the different pressure belts: equatorial low pressure belt, subtropical high pressure belt, then we have a subpolar pressure belt, and then we have a polar high pressure. So these are the pressure belts that are present on the Earth's surface. So there are 7 pressure belts that has developed. Now what are the factors which control the pressure? So there are 2 factors that you need to know. There are 2 factors of atmospheric pressure. So factors of variation of atmospheric pressure, one is a thermal factor and another one is a dynamic factor. So there are 2 factors. So pressure is associated with either thermal factor or the dynamic factor. Thermal factor is nothing but the temperature, and dynamic factor is simply the movement of air. So thermal factor is the temperature and dynamic factor is associated with the air movement. Now here itself you can learn one very important thing, that most of the phenomena on the Earth's surface, climatic phenomena, most of the climatic phenomena on the Earth's surface is more or less is associated with the insolation only. So if it is the insolation, then it is quite obvious that most of the atmospheric pressure should be associated with the thermal. But why we have another factor that is dynamic, and from where this dynamic factor is coming? So what you just need to remember, this dynamic factor is coming from the fact that Earth is not a static object. Earth is a dynamic object, means Earth continuously rotates on its axis. So because of this Earth rotation, there will be a dynamic effect that will be witnessed on the Earth's surface, especially for the moving object. So anything that is moving on the Earth's surface, freely moving. So freely moving में आपका जो atmospheric movement है उसमें wind है. So wind always gets affected, air will always get affected by the Earth rotation. और ये जो अर्थ रोटेशन की वजह से इफेक्ट आता है उसको हम लोग कहते हैं कोरियोलिस इफेक्ट. सो कोरियोलिस इफेक्ट क्या है वी विल सी, बट हियर जस्ट द ओनली थिंग दैट यू नीड टू नो दैट इफ इट इज नॉट बिकॉज ऑफ द टेम्परेचर देन इट विल बी डायनेमिक. तो टेम्परेचर का कैसे इफेक्ट है और डायनेमिक कैसे इफेक्ट है वो देखिए, समझने का ट्राई करिए. हाई टेम्परेचर, if the high temperature is there, pressure should be low, because high temperature means air will be warmer and warmer air will have tendency to rise. Temperature high है और अगर आपका temperature high है तो air आपकी गर्म होगी and warm air will have tendency to rise because it happens to be the lighter. So high temperature should be low pressure and low temperature should be high pressure. In other word, if pressure is inversely related, temperature नहीं देखना, pressure देखना, because we are looking out the pressure, not the temperature. Temperature कैसे कैसे vary होता, we already have looked out. So that those are the only factors that affect the temperature. So don't try to link the temperature with the pressure. It is pressure that is associated with the temperature. So if in any area you are witnessing high pressure, if it is a high pressure means chances will be that area should have a low temperature. So if the pressure is high and temperature is low, we can say that this pressure is being developed due to the thermal factor, और इसे हम लोग thermal pressure कहेंगे. Similarly, if in any area we are witnessing the low pressure, and if it is low pressure, so it should have the high temperature, and if that area is having high temperature, means that pressure must have been associated with the temperature. But look out the another way. We are witnessing in any area as a low pressure. Now if there is a low pressure, so temperature related it should be high temperature. But what we are witnessing, that pressure is low and temperature is also low. If the temperature is low, in spite of having the low pressure, means the pressure is not being controlled by the temperature. Similarly, any area is witnessing high pressure and the temperature is also high, so means pressure is not being controlled by the temperature. So when the pressure is not being controlled by the temperature, in that case, that pressure is known as the dynamic pressure. If the pressure is being controlled by the temperature, that will be the thermal pressure. अब यहाँ पे देखेंगे अर्थ सरफेस पे. When you will look out the earth surface, distribution of the pressure, what you will find that we have equatorial low pressure belt. Equatorial pressure belt is having a low pressure. So equatorial zone is having a low pressure, and here we have a low pressure, and we know that equator we have a high temperature, not the highest, high temperature. So equator has high temperature, so temperature is high, pressure should be low, and exactly the pressure is low. So we can say that this pressure is being associated with the thermal. We can say that this is a thermally induced pressure. Very similarly, when you will look out the higher latitude, that is the poles. So in polar area, what happens? In polar area, temperature is low, so pressure should be high, and in fact here we are witnessing the high pressure. As we are witnessing the high pressure in the polar area, it means that it is also being associated with the thermal pressure. So in low latitude, temperature is high, pressure is low. In higher latitude, temperature is low, pressure is high. It means these three pressure belts are the thermally induced: equatorial low pressure, polar high pressure, polar high pressure. But when you will look out, subtropical zone, we know that subtropical zone is a zone where we have the highest temperature. In fact, it is the subtropical, northern subtropicals, where most of the deserts you will find. So it is the subtropical zone where most of the deserts are located. So temperature is obviously very high, and if the temperature is very high, pressure should be low. But what we are witnessing? Pressure is high. So subtropical area, temperature is high, pressure is also high, means pressure is not being controlled by the temperature. So obviously it is a controlled by dynamic factor. There must be some of the region, there must be some of the movement. Because of that, huge amount of air is being forced to sink. When huge amount of air is forced to sink, basically what happens? Equatorial area we have a low pressure, means air is rising. All the air that rises from the equator over the period of time will travel toward the polar area. When it is traveling toward the polar area, it will get affected, diverted by the effect of the Coriolis, and ultimately all the air will be forced to sink around that 30-35 degree latitude, and due to sinking of huge amount of air, there will be a formation of this subtropical high pressure zone. So subtropical high pressure zone will get created because of the sinking. So it is a high pressure area that is dynamically developed. Very similarly, when you will look out the subpolar area is not having as low temperature at the poles, but still you will have the low temperature. And when the temperature is low, we will expect that here we should have the high pressure, but what we are witnessing? The low pressure. So in spite of having low temperature, pressure is low, it means that pressure is not being controlled by the thermal factor. So this is also the dynamic factor. So dynamic factors plays very important role in the distribution of the pressure. 4 pressure belt on the earth surface, that is subtropical high pressure, subpolar low pressure, subtropical high pressure, subtropical high pressure, subpolar low pressure, subpolar low pressure. These 4 pressure belts have been developed dynamically, and 3 pressure belts have been developed thermally. So, there are 3 pressure belts that are thermal pressure belts and the 4 pressure belts that are dynamic. Now, dynamic, as we are looking out, dynamic का role कैसे है? So, the dynamic pressure belt is associated with the Coriolis effect. Now, what is this Coriolis? Quickly look out. Because of the Coriolis force, all the freely moving objects gets deflected rightward in northern hemisphere and leftward in southern hemisphere. So, all the freely moving objects, any freely moving object, all the freely moving objects get deflected rightward in the northern hemisphere and leftward in the southern hemisphere, irrespective of the original movement. So, it is like if actual movement, original movement is this, so we are in the northern hemisphere. So, in northern hemisphere what will happen? Because of the Coriolis, it will get deflected rightward. So, this will become actual. It is the original, it will become actual, rightward. Similarly, if we are in southern hemisphere, so southern hemisphere deflection will be leftward. This is actual and this is original, initial. So, all the freely moving objects get deflected rightward in the northern hemisphere and leftward in the southern hemisphere. तो rightward आपका north में, leftward आपका south में. The second effect of the Coriolis, this is movement, the second effect of the Coriolis is, because of the Coriolis, only direction will change. So, Coriolis will affect the direction, not the speed, So, it will affect the direction, not the speed. Also, because of the Coriolis, only direction is getting affected, not the speed, but Coriolis is directly associated with the speed, means higher the speed, higher will be deflection. So, higher the speed, higher will be deflection. Lesser the speed, lesser will be deflection. Means if you are launching the rocket and if you are firing the bullet and if the bullet speed is comparatively lesser, so obviously bullet will get deflected lesser in comparison to the rocket. So, whosoever the speed will be higher will have more deflection. And the last point is, deflection is almost negligible near equator, whereas the highest over the poles. Means because of the Coriolis, what happens? The Coriolis deflection keeps on increasing. Highest deflection in the poles, lowest deflection in the equator. Highest deflection poles, lowest over the equator. In fact, over the equator roughly negligible. And this Coriolis effect is very much responsible for the development of the 4 pressure belts. and in fact those 4 pressure belts, because initially people were not aware of, they have also got some name, some different names, and effect of this pressure belts is being witnessed in the form of wind. तो जो हमारी wind है, horizontal movement of air, horizontal movement of air is simply known as the wind. तो ये जो आपका horizontal movement of air है, it is the resultant of nothing but the pressure gradient. Whenever you will have the two places, let's say place A and place B, horizontally these two places will have a two different pressure. One of the places is high pressure and another is low pressure. The air will start moving from the areas of high pressure to areas of low pressure. And when the air will move from the areas of high pressure to areas of low pressure, this movement of air from the areas of high pressure to low pressure is simply known as the wind. Wind will be categorized on the basis of where it is blowing, what is the extent of blow, but primarily we have a three major categorization of wind, that is the global wind, जिसको permanent wind भी कहते हैं, then we have a seasonal winds and the local winds. Quickly we will look out, because we already have learned the pressure belts, so it will not be difficult for you to look out the permanent or planetary winds. तो permanent और planetary winds हम लोग देखते हैं. Permanent or planetary winds. So we have a equatorial low pressure, subtropical high pressure, subtropical high pressure, subpolar low pressure, subpolar low pressure, polar high pressure, polar high pressure. So these are the pressure distribution. Because of the pressure distribution, the air will start blowing. Now in this subtropical high pressure, this subtropical high pressure zone is also known as horse latitude. तो इसे horse latitude भी कहते थे. Why it was being known as the horse latitude? Because in earlier time period people were very much known to, they were having a awareness about the thermal pressure only. So they were knowing, they were thinking that on the surface we have a low pressure is prevailing in the lower latitude and high pressure is prevailing in the higher latitude. But when they were encountering, when they were traveling in these areas, suddenly they were witnessing that the pressure is increasing, and when the pressure is increasing, so sailing will not be easy, and most of their ships materials will start getting drowned. So to save themselves from the drowning, they will start throwing the materials, and most of the materials will be thrown, and ultimately they will also throw their most loved belongings, that is the horses. That is how it got its name. So sailors ने ही दिया है ये नाम horse latitude. So here we have subtropical high pressure, here we have equatorial low pressure. Air will blow from the subtropical high pressure to equatorial low pressure, and this movement of air is not only limited to the one hemisphere but in both the hemisphere. So air will blow horizontally from the subtropical high pressure to the equatorial low pressure, and this air that is moving horizontally is simply known as the wind, और इसे हम लोग क्या कहेंगे, trade wind. So trade wind is limited to the low latitude within the zone of 30 degree to 30 degree. So 30 degree north, 30 degree south, you will find we have the presence of trade winds, and in trade winds we have the two trades, north easterly trade and the south easterly trade. So northeasterly trade and the southeasterly trade. The zone of convergence of this trade wind, so zone of convergence of trade wind is known as intertropical convergence zone, that is ITCZ. So please be very clear, this intertropical convergence zone is a low pressure zone. Intertropical convergence is a low pressure zone, and intertropical convergence zone is developing through the convergence of two trade wind, that is northeasterly and southeasterly. The general extent अगर आप देखेंगे तो 30 degree north to 30 degree south है, but in other cases you will not find this extent. तो थोड़ा ध्यान, so please be very careful, ध्यान रखिएगा क्योंकि क्वेश्चन पहले भी पूछा गया है, आगे भी पूछा जाएगा. So please be very careful that this 30 degree to 30 degree we have a trade wind, but that is not going to be applicable in the, let's say next zone is 60 degree north, 60 degree south. अब ये जो आपका नेक्स्ट जोन है 30 से 60 नॉर्थ में है, 30 to 60 साउथ में है. So it is not like 60 degree north to 60 degree south you will have a presence of westerly. So please be very careful about statement like this. जब भी आप wind का extent पूछा जाए, so please read the question properly, carefully, that what exactly they are asking, what type of question they are asking, उसका भी थोड़ा सा आप ध्यान रखिए. Next zone, we have a subtropical high pressure to subpolar low pressure. Here we have a movements of air in such a manner that it will start blowing like a westerly. तो westerly की तरह से blow करेगा. So this is known as westerlies. Now the westerlies, जो आपकी westerlies हैं, westerlies blow from subtropical high pressure to subpolar low pressure. So subtropical high pressure से subpolar low की तरफ जो आपकी wind blow करती हैं, that is the westerly. Westerlies blow in both the hemisphere, northern and southern, but the westerlies happens to be more powerful. Westerlies will be more powerful in the southern hemisphere, and because the westerlies are more powerful in the southern hemisphere, their extent is higher. So almost they will be present between 30 to 70 degree. तो लगभग 70 डिग्री तक आपकी एक्सटेंट हो सकती है वेस्टर्ली की. And in southern hemisphere they will be named differently, like roaring 40s, furious here I am writing. Roaring 40s is 40 degrees south. Furious 50s 50 degrees south. Also shrieking 60s 60 degrees south. So roaring 40s, furious 50s, shrieking 60s. These are the names of westerlies in southern hemisphere given by the sailors. Also, here comes very interesting fact. Westerlies are more stronger, more powerful in the southern hemisphere. Because westerlies are more powerful, their speed is higher, so it's quite obvious that the deflection of the westerlies will be more in the southern hemisphere. So deflection of the westerlies is more not because of the different nature of the Coriolis in the two hemisphere. It is simply the characteristic. Coriolis efficiency will be same as in northern hemisphere, in southern hemisphere. But because in southern hemisphere westerlies are more stronger, that is why you will find that the deflection will be more. The last wind, it will be from the poles to subpolar area. So, from the poles to subpolar area in the form of polar easterly. Polar easterly. So, we have a 3 sets of the wind, that is trade winds, westerly, polar easterly. So, these are the 3 planetary wind, these are the 3 permanent wind. Out of these 3 permanent wind, it is the polar easterly that are extremely dry because of the prevailing cold condition. So, in higher latitude, temperature is very low. Temperature is very low. Because of this low temperature, the air, the wind is so cold that the wind is incapable of carrying the moisture. So, the only place where the wind is not capable of carrying the moisture, holding the moisture, is the higher latitude, and it is the polar easterly. So, polar easterly is almost divide of any moisture. So, that is also clear from the water vapor. तो water vapor का भी जो distribution था उसमें भी आप देखेंगे low latitude, higher latitude is almost not having the presence of water vapor. So, these are the 3 permanent winds, planetary winds. From here also you will get plenty of questions regularly. Every year they ask the questions, and most of the questions happens to be very basic. The only thing that you should have clarity of the wind, and the second thing is that you should be you should not confused, and whenever the question will be asked, always it will be better to draw the diagram in the examination, because in the examination because of the examination pressure, sometimes you don't read the question properly. So, it will always be better to just draw the diagram, whatever the statement they are saying, and check that whether the statement is correct according to the diagram or not. Now, moving to the next discussion, and next discussion will be associated with the condensation. So, the next discussion is associated with the condensation. For the condensation, there are 2 things that you need to know. One is a humidity concept, and the second is how the heating and cooling happens in our atmosphere. So, 2 additional concepts, humidity and heating and cooling general in atmosphere. So, these 2 additional concepts we will learn. First, humidity. Humidity is nothing but it is the water vapor present in the air. So, amount of water vapor that is present in the air is nothing but that is the humidity. Higher amount of water vapor, higher humidity. There are different methods of measurement of the humidity. We have the specific humidity, absolute humidity, relative humidity. For convenience, because of the nature of movement of air, we look out the relative humidity. Which we simply call it as RH. So, in our atmosphere we will use the RH or relative humidity. What is this RH or relative humidity? A relative humidity is simply the ratio of actual amount of water vapor present in the air to the maximum amount of water vapor air can hold at that given temperature. So, at that given temperature, what the maximum amount of temperature it can hold is simply known as the relative humidity. So, relative humidity is the ratio of actual amount of water vapor present in the air to the maximum water holding capacity. One more thing, this maximum water holding capacity will decrease, will be directly associated with the air temperature. Higher the air temperature, higher will be the water holding capacity. So it's quite obvious. During the summer season you will find that when the temperature is higher, air is comparatively more capable of holding the moisture in comparison to the winter. So humidity. The second thing is how this general heating and cooling happens related to the air. We call it as adiabatic process. Adiabatic process. तो adiabatic process क्या है समझ लीजिए. Very simply, ground है. From the ground, as you will go up, temperature decreases. As you are going up, as you are moving away from the ground, temperature is decreasing because you are moving away from the heat source. That is applicable for in general. But when you will look out a specific any particular parcel of air, let's say we have a parcel of air. If this parcel of air is going upside, what will happen? This parcel of air's volume will changes because as it will go up, what will happen? There will be change in atmospheric pressure. Because of change in atmospheric pressure, as this parcel of air is going, as this parcel of is rising, there will be a change in temperature. And this change in temperature is without any exchange of heat. यहाँ पे कोई heat आपकी neither the heat is being taken nor the heat is being given. So whenever any parcel of air or any system is witnessing the change of the temperature without any actual gain or loss of heat, without any actual exchange of heat, that change is simply known as adiabatic process. So adiabatic process is change of temperature without any actual exchange of heat. So the change of temperature without any exchange of heat is simply known as adiabatic process. Adiabatic process can be both positive, negative. So adiabatic process is like increasing temperature, so adiabatic heating, decreasing temperature, adiabatic cooling. So adiabatic heating, adiabatic cooling both happens. The only thing that is responsible for this adiabatic change is the change of volume, and change of volume is associated with the pressure. So if the parcel of air is expanding, तो ये expanding कब होगा? When it is rising. When it is expanding means there will be drop in temperature, उसको आप कहेंगे cooling. In other word, air is rising means air will experience, it will witness cooling. तो जब भी आपकी air rise करेगी एटमॉस्फेयर में, there will be adiabatic change, and because of that adiabatic change, there will be drop of temperature. और जैसे ही आपकी air ऊपर से नीचे आएगी, when the air is sinking, the air will experience more atmospheric pressure. Because of higher atmospheric pressure, there will be contraction, and as it will witness contraction, there will be increase in temperature. So keep it very simple. एक simple तरीके से आप इसे समझिए, but this is the actual process. In our atmosphere, the only thing that you need to remember, in our atmosphere, whenever the air is rising, so air is rising means adiabatic cooling, and whenever the air is sinking, it is adiabatic heating. means whenever the air will rise, air will get heated up. Whenever the air is sinking, air will get heated up. So, air is rising, air will get cooled up, air is sinking, air will get heated up. That is the reason why if there is a mountain, along that mountain if the air is rising, so along the mountain air is rising means air is getting cooled up, but along the same mountain, other side of the mountain, if the air is going downward, it is sinking, so the air will get heated up. So, if in any mountainous area, if air is sliding down from the mountain top, so that wind will be the warm wind, because whenever the air is going downward, there will be adiabatic heating. So, this is very simple. One more thing, जो moisture आपका है, moisture water vapor, that we will refer in the terms of humidity. So, humidity, as we have discussed that there are different methods of measurement of humidity, but the method that we apply, that method of humidity is simply known as relative humidity. So, here one more thing that you always you can link up, whenever the air is rising, air is getting cooled up adiabatically and its RH will increases. So, air is rising, adiabatic cooling, RH will increases, and here we will have opposite, air is sinking, adiabatic heating, RH will decreases. RH आपका जब भी ऊपर एयर जाएगी, इस तरीके से भी याद कर सकते हैं, एयर आपकी ऊपर जा रही, RH ऊपर जा रहा, एयर आपकी नीचे आ रही, RH आपका नीचे आ रहा. So, air is rising, RH will increases, air is sinking, RH will decreases. Now, the interesting fact is, when the RH is increasing, then only we have the possibility of 100% RH, because if the RH is decreasing, so there is no possibility of reaching 100% RH. So, RH 100% is only possible in case of rising. So, whenever the air is rising, adiabatic cooling will happen, resulting into the increasing RH, and when the RH will become 100% means air has the maximum water holding capacity. That condition is known as saturation, and after the saturation, if there will be any further decrease in temperature through the rising, then we will witness condensation. Condensation is nothing but it is the transformation of water vapor into liquid water or ice crystal. So, condensation is nothing. Condensation is simply the transformation of water vapor, and water vapor is where is the water vapor? Water vapor is with the air, and from where the air has got this water vapor? Air has got this water vapor from the surface. So, from the surface, air will got the water vapor. This water vapor will be taken by the air, and whenever the air is rising, air will get cooled up. Because of the how the air is getting cooled up? Through the adiabatic cooling. So, when the air is rising, there is a adiabatic cooling. Because of adiabatic cooling, RH will increases, and when the RH will reaches 100%, there will be saturation. After the saturation, there will be condensation, and condensation will take place at the temperature that is known as the dew point temperature, and depending upon the dew point temperature, we can have the possibility of the different forms of the condensation, and one of the form of the condensation, the most common form of the condensation that you should not miss is the cloud. तो ये जो आपका cloud है, cloud is nothing but it is the form of condensation. Condensation से ही आपका cloud बनता है. So quickly we can look out the cycle, general cycle of condensation. rising of air. Rising of air will happen. This rising of air will result into adiabatic cooling. Because of adiabatic cooling, a relative humidity increases. Now, when the relative humidity will reaches 100%, that situation is known as saturated air, and if there is a further rising, then there will be condensation. Condensation will take place at dew point temperature, and after the condensation there will be a formation of the clouds, and after the cloud there will be a rainfall. Now, here there are two interesting information that you should not miss. The first information is all the clouds will not rain. So, all the cloud is not resulting into the rainfall, but rainfall will always be associated with the clouds. Rainfall will always be associated with the cloud. The second thing is condensation will have a forms, and one of the form is cloud. And starting itself I made it very clear that condensation is transformation of water vapor. So, this is a confusion, and this is not a confusion that is limited to the small scale student. In fact, majority of the student will have this confusion. They are not having the clarity that what cloud is made up of. So, cloud is either made up of ice crystal or the water droplets. This is very important. So, cloud is primarily made up of either water droplets or the ice crystal. Cloud is not the water vapor, because cloud is after the condensation. Condensation has taken place, and condensation is simply the transformation of water vapor into either water droplets or the ice crystal. So, this is the general life cycle of the rainfall. Here comes the condensation. Let us have a brief discussion about the condensation, because condensation is something from where they regularly ask the question. Condensation, when we talk about the forms of condensation, so we have two different forms of the condensation. When the dew point is above the freezing point, in this case we have the clouds, we have dew, we have mist, we have fog, we have frost. And when the dew point is less than 0 degree, in this case we have clouds, also we have a frost. Here it is not frost, it is smog. So, when the dew point is above the freezing point, then it is like clouds, dew, mist, fog, smog, and when the dew point is below the 0 degree, it is clouds and frost. But these are the forms of condensation. But in these forms of condensation, you will find this is not associated with the typical life cycle of the rainfall that we have learned. So, depending upon the dew point temperature, we can categorize the condensation will have a two different form. But condensation can also be differentiated depending upon the form. One of the condensation is known as atmospheric condensation. Atmospheric condensation means the condensation that is happening in above atmosphere, that we already have discussed. Air is rising, rising air will witness adiabatic cooling, decrease in temperature, relative humidity will increases, RHS reaching 100% saturation of the air, then condensation. The second form of the condensation is simply known as ground level condensation. Now, the ground level condensation is simply जो हमारा ग्राउंड लेवल कंडेंसेशन है, ग्राउंड लेवल कंडेंसेशन इज सिंपली एसोसिएटेड विद द डिक्रीज इन टेम्परेचर ऑफ द एयर, बट दिस डिक्रीज इन टेम्परेचर ऑफ द एयर इज नॉट बिकॉज ऑफ द एयर इज राइजिंग। तो ये जो एयर हमारी है, एयर नहीं राइज कर रही है, तो एयर आपकी राइज नहीं कर रही, बट स्टिल टेम्परेचर इज डिक्रीजिंग। और जब हमारा टेम्परेचर डिक्रीज हो गया बिकॉज ऑफ दिस, सो वहां भी हमारा कंडेंसेशन पॉसिबल है, उसे ही कहते हैं ग्राउंड लेवल कंडेंसेशन। सो ग्राउंड लेवल कंडेंसेशन जो हमारा है, हाउ दिस ग्राउंड लेवल कंडेंसेशन हैपेंस, सो इसके लिए आप याद कर सकते हैं ग्राउंड लेवल कंडेंसेशन हैपेंस थ्रू द टेम्परेचर inversion. Temperature inversion will produce ground level condensation, and ground level condensation will have a form dew, fog, mist, smog, frost. These are very common. So these are very common especially during the winter season. तो winter season में आप देखेंगे कि majority part of the urban area we have a problem of fog. Fog mixed with the smoke, then it will become smog. And sometime the temperature will reaches up to the freezing point, it will result into the frost also. So what is this temperature inversion? So let's have a quick discussion. Temperature inversion. So temperature inversion. Now temperature inversion का form क्या क्या है? We have a dew, mist, fog. So if they are asking about the formation of the dew, how the dew will form? How the dew will form is nothing but temperature inversion. So temperature inversion is nothing. Generally in our atmosphere, temperature decreases with increasing height. So temperature decreases with increasing height, but sometime general pattern of vertical change of temperature gets inverted. Means in spite of rising, now it has started exhibiting like the characteristic of, it is not decreasing, rather it is increasing. So generally our expectation is that whenever we are rising, whenever we are going upside, increasing the height, temperature should decrease. But यहाँ पे अब क्या हो रहा है, टेम्परेचर आपका डिक्रीज ना करके इंक्रीज, बेसिकली इंक्रीज नहीं कर रहा है. व्हाट इज हैपनिंग, इसको भी आप समझ लीजिए, ऐसा कंफ्यूजन ना रहे. लो लेट्स से मिडल, जनरली यहां पे हमारा टेम्परेचर लेट्स से 10 डिग्री सेल्सियस है. हियर वी हैव टेम्परेचर ऑफ 5 डिग्री सेल्सियस. तो हमारा नीचे लोअर साइड वी हैव अ हाई टेम्परेचर, अबव वी विल हैव अ लो टेम्परेचर. दिस इज द जनरल पैटर्न. But imagine that there is some phenomena, because of that some phenomena, because of the contact with this surface, now this air that earlier it was 10 degrees Celsius, now it has come down to 3 degrees Celsius. So once the air that is in contact with the surface is getting cooled up, it will start exhibiting like this air is cold and above is warm. So it is not that when you are going upside there is an increasing pattern, ऐसा कुछ नहीं है. So nothing like that, but still you will find that in case of the general pattern has got inverted, that is simply known as temperature inversion. So temperature inversion is nothing but when the lower part of the air is exhibiting lesser temperature in comparison to the air overlying. Now the temperature inversion will happen in some of the conditions. So the general condition for the temperature inversion, so what is the general condition for the temperature inversion? Long cold winter night. So it should be long cold winter night. When the dew will form when there is a long cold winter night. When the fog will form when there is a long cold winter night. Other than this, there should be clear sky. When you will have the cloudy nights, so during the cloudy night, first of all temperature will be higher, because the radiation that the earth is radiating will get radiated back. some of the clouds are known for absorbing. So radiation आपका re-radiate होगा तो surface का जो temperature होगा बढ़ेगा. It is also very obvious and you should be knowing that the cloudy nights are warmer than the cloudless sky. So cloudless nights are happens to be comparatively cooler. So clear sky, long cold winter night and no vertical movement of air. So when these conditions will prevail, in these conditions definitely the ground level condensation happens. Like ground level condensation mostly occurs in India during the winter season, and it is because of the extreme level of cooling. So ground gets extremely cooled up and the air that is in contact with the surface will also get cooled up over the period of time. It will witness the ground level condensation. Other parts of the world, condensation can happen because of the vicinity of the cold ocean current. There are different processes, phenomena through which the temperature inversion can happen. Temperature inversion से भी question पूछा जाता है, so regularly they ask the question related to the temperature inversion. They have asked several times how the dew will form, when the dew will not form, when the dew will form. So these are the conditions. Temperature inversion have the most obvious effect in the form of fog. So fog is majority of the cases fog is not good, but in some of the cases fog is good also. So these are the some of the important concepts related to the climate that I have tried to cover. And if you will go through these concepts, believe me, at least whatever the number of questions, because sometimes it can be like 5 questions, sometimes it can be 2 only, but definitely there will be few questions from the, if they are asking the question from the geography, majority of the questions will be from the climate and the mapping. So just try to cover these components seriously, and definitely it will be going to be highly beneficial for your upcoming prelims examination. That is all from my side, and wish you all the best for your upcoming prelims examination, and continue watching the sessions of our prelims probable. In that we will come out with the next component in the next session. So that's it for today. Thank you.